Welcome back to the MPCNC livestream build series. Country 3D is already here, noticing that I'll be at Earth. I'll see you all at Earth. But yes, today we have, I guess, almost the final steps of assembly for this MPCNC. So yesterday we ended on the gantry, or the middle piece, I guess, being assembled, where we have a Z-axis that works. We have a motor in here. So today all that's left is, I mean, if you look at the parts here, the parts are kind of diminishing. There's not much left here. So we have the motor mounts that actually go on on these end pieces here. That's gonna mount one NEMA 17 each. Then we need some belts. The belts run from each leg through the motor, through these bearings, then up to the motor, back down, and then back into these leg pieces. We need to square the frame, and we also need to set the height on each of these corners because these are not locked in yet. So that's all something that we do today. So let's jump over into the... come on, why do you do this? Display capture. OBS Studio does not like it when I turn screens on and off. So yes, yesterday we built the middle assembly, this massive beast of a part. So today, Gantry. Gantry sounds like we've already done that, but Gantry is actually the motion system. So yeah, I did originally think this machine would only have 3 separate motors, X, Y, Z, right? But like thinking about it, it makes sense that it needs 5. So I have found 2 more stepper motors that, yeah, I can use. You do need identical ones, I believe. Well, at least it's best to use identical ones. So 2 of these are going to go on the Y-axis. Yes, left to right is the Y-axis. And then I have this one and this one. And I believe these are identical ones. Long's motor... Let's see, Long's motor 42 BYGH 0425, 2.5 amp, 1.8 degree. These are, I think, the oldest motors that I have. So yes, these are going to go on some other axes. Just got the notification. What did I miss? Burly is asking. Not much. We just started 2 minutes ago. You have missed nothing. It's good to hear that YouTube notifications are properly working, at least for today. It seems like they're sometimes just slightly delayed, but seems you guys got them all right. So cool. Zoom zoom. Oh, is that trademarked? So simple assembly. Motor goes in here as per the instructions. You do need to keep an eye out for where your cable comes out of the motor, because you can mount them either way. I don't think you want to do it like that, because that's actually going to have the cable jam into your rod there, into your tubing. Really, I'm going to have cables on here that are so long. Yeah, it's not really going to matter. So these all use the standard M3 by 10 screws. And I think, oh no, that's actually the wrong one. Cool. So there you go, there's that. Why not stream on Mixer? Mixer really is oriented towards game streaming, and it does not look like they even have a category for what I'm doing here. So yeah, YouTube, I mean, I have you guys here on YouTube. You probably wouldn't be watching on Mixer. That is too much torque. Yeah, thank you for the $2.99, Wasi Herbert. glad that I'm getting people inspired to print their own machines and to have this machine ready when it's, or hopefully ready when I'm ready. That would be awesome if I start early and you guys get inspired and just start printing parts and we kind of finish at the same time. I mean, that's the best kind, right? How much does the Gantry weigh? Yours is 3.1 kilograms. I don't know how much this Gantry weighs. I don't know whether the Gantry is actually the entire part, so this entire bobbin, or just like the middle section, but I think 3.1 kilograms is not enough. I think it's a bit heavier than that. These are chunky tubes. These are, you can actually do the math on how heavy these actually are. These are 25 by 2 millimeter tubes. They're 80 centimeters long. So you can just use the density for iron or steel. And you should get a pretty good idea of how heavy this entire thing is, plus printed parts and bearings and all that. A lot of mass to move. Yes, that is correct. But I mean, so you can use this as a 3D printer, obviously, because it's, I mean, X, Y, Z. That's all there is. You add a, can you guys actually see that? Yeah, you can kind of see the tool mount there. Oh, I just realized I kind of screwed up. We'll get to that in a second. But there is space, obviously, where you can mount an extruder and a hot end. But the thing with all this mass, and you can kind of see how well this just rolls on its own because of inertia and all that. Because of that mass, it's not going to be doing like super tiny infill really quickly. I mean, I'm having a hard time actually pushing it fast enough for that. So for CNC milling, it kind of doesn't matter that it's that heavy. Actually, mass is good for that, because you do want, you know, you do want that inertia when you're milling stuff. You don't want the cutter, when it engages the material, just plopping or bouncing the entire machine around. So inertia is good for milling, but for printing, not so much. Any plans to add the fourth axis later, Terry's asking. I've actually thought about whether I could even add a fourth axis. And the thing is, my z-axis is I think not far up enough, or I would need to mount the tool further up, because there's not really a lot of space between the end of this middle piece and the base plate. So if I had a fourth axis, it would be really high up, and the tool would need to be really high up. So I don't actually think that would work. And Ryan from V1 Engineering, the designer of this machine, is also here. Welcome back. Have you thought about laser cutting or engraving, or laser engraving? I am scared of lasers. I'm wearing glasses, so I kind of know how much it sucks to be like visually impaired. I mean, like not legally blind or anything, but I have 3.25 dioptrin on both eyes. Kind of sucks getting out of bed in the morning and having to look for your glasses if you don't know where they are. So I do value my eyesight a whole lot. And so far, I've not found a good solution when it comes to like dealing with laser stuff on machines that don't have an enclosure. Like this one is 100% open. If you just have a laser on here, like it's not shielded by anything. So yeah, I'm not super keen on getting into laser stuff on a DIY basis. It's cool and all, but I don't think it's worth the risk. Okay, we have mounted the motors, all 4 of them. So now we install the pulleys. And then back it out of that. Yeah, these are high quality pulleys. I got the highest quality. No, I just got the cheapest AliExpress special pulleys. These are 16 teeth, so you get a bit more torque out of your motors, which this machine definitely needs. But they're actually pretty well made now, because they've become a commodity product. You can get some really good pulleys for fairly cheap now. Trendment, how did last stream go? Went well. We got the entire, I mean, look at it. It's assembled for the most part. So yeah, so it looks like the set screw actually goes towards the outside, and this inside face, so this inside shoulder of the pulley, just needs to protrude ever so slightly from this face. So basically, these are the ones that have the actual flat on them. The other ones I've because again, these are like my OG motors that I built my first pusher spindle with. These have a filed flat on them. I'm hoping I can get you guys a bit of a view from this perspective, maybe. There you go. So yeah, and this one has a nice flat on it that we can screw to, so it just goes on like, well, I guess I need to back out these screws first. Do you need end stops? That is a good question that I can talk about while I'm assembling these parts. So I'm actually I'm not planning on using end stops with this machine. I don't have end stops on the CNC. I don't have, well, I do have end stops on the Mendel Max, but for CNC milling, you're always going to be aligning your zero with your workpiece. So for the most part, unless you're just plopping down a full 50 by 50 centimeter sheet onto the build surface or into the workspace, and you know exactly how big your part is, or you have like a center bracket there.
Did you mention in another video why they choose this kind of bearings rainbows instead of linear bearings?
I'll get to that in a second. Let me finish this first. Yeah, unless you do that, or you have some sort of a corner brace right here where you just slide your work into the same corner every time. So you kind of reference that and have the end stops reference that same position, which I don't think I'm going to be doing a whole lot on this machine. Well, maybe I will, since it's so big. Like that's the obvious thing to do. But unless you're doing that, there's no real advantage of having end stops. Like, yeah, if you mount a vise somewhere, you're going to have a position where you can reference that vise, maybe, but that's going to move. I just think for the amount of milling that I'm going to be doing, it's fine to just manually touch off on the part and adjust your center like that. Plus, end stops aren't 100% repeatable anyways, so for milling, like, that can be an issue too. Yeah, so Ryan is saying the end stops are used more for accurate squaring than for actual homing, which makes sense. So to get to the question from Matthew, by the way, thank you for the €5. Did you mention in another video why they chose this kind of bearing assembly instead of linear bearings? I did not, so I've not gone over that yet. By the way, these grub screws could definitely do with some thread lock, but I can always add that later. So check these regularly. Why the honestly somewhat weird bearing mega assembly that has 3 roller bearings on each shaft? Now, this kind of reminds me of the Salesmendel, which was my very first 3D printer that I built. By the way, look that up if you don't know it. It's a piece of cultural or 3D printing history. The Salesmendel used a very similar system where it was 3 like radial bearings like this around every rod. They were already using the 8mm rods back then. What's up with this pulley? But they did use radial bearings for each of them, and that was a bit of a mess and kind of unnecessary. And people did try like all sorts of weird things, like print PLA bushings and use like pieces of cloth in there, or then people discovered, oh, we have this company called Igus that actually makes these parts. And then there's pulleys that apparently have a lot of swerve towards the inside where the grub screw goes through. But and then obviously the LM8U bearings came up. But the thing is with the... Is this shaft damaged somehow? Oh yeah, it looks like this shaft has a bit of a burr from... Where's my camera? There's my camera. Is it just... You can maybe see that, yeah, there's a little notch from the from a grub screw that went on earlier. But yeah, why this assembly? I don't know, honestly. I'm thinking, so I'm guessing here. I'm thinking that it's cost because you do combine structure into linear guides, and the typical, yeah, price exactly. The typical linear rails like the MGN 15, etc. They always, or they should be used with some sort of backing, like aluminum profile, machine profiles, those sort of things. That does add to the BOM, that does add cost, that does add assembly time. And when you're using 3D printed parts, I think what's being used here is okay. Oh, but then again, thinking like these bearings do also add a bit of BOM cost to the machine and, you know, assembly time. Okay, maybe a bit of a moot point, but yeah. I don't know. It's the way it is. It's the way it is. I guess you could go either way. I think this way is a bit more DIY-able than going with MGNs, because you do need some sort of aluminum rail, and you know, you can build these parts instead of just buying the full carriage. I don't know. You can go either way. If you prefer one version, you can find a CNC build that uses that. But with 3D printed parts, this might work better. Ooh, Jens is pointing out tool stores or many stores sell 25mm tubing as 1 inch. That's going to be a bummer if you don't notice and you print all the wrong parts for the wrong size. I mean, it's just 0.4mm, but it's still going to be off. Like the tensioning is going to be way off, and all of that. So do double check your tubing before you print parts. I know this was sold as metric, and metric usually means the exact dimension. All right, so we do have the pulleys on. It'll just be a millimeter or two from the mount face. We do have that. Yes, snug them up. We did do that. So fit the lock nuts in the rollers. Very lightly put in these screws. There's no reason to get these super tight. The rails are going nowhere, and when you add the belt, it only increases the tension. Okay, so these obviously right now still are loose. So there are little slots back here where you add nuts, and then you just screw it down through the top from this side. There's the screw holes that actually attach it to these carriages right here. So let me find which lock nuts and these screws the instructions mean. I'm thinking it's an M4x20 again. I'm guessing it's these and these. Let me try it. So, ooh, that's going to be a pain to tighten again because there's nothing holding in this nut. It just goes, it's a hexagonal nut that goes in a slot. Then M4x20. Hole is a bit tight, but we can always force it in. The worst of the 4mm nut slots. Okay, so this is this. I'll get the screwdriver ready. There it is. So just like before, I'll show you up close on the other slots, but it's actually not that bad because you can slot the screwdriver in pretty well. You just need to know that you actually need a screwdriver. So that went pretty well, I'd say. Let's try the other one. So nut goes in here. I'm sorry, I don't have a zoom on the front camera yet. I'll probably set that up for some future stream. So right now the nut is just spinning loose. Yeah, there's the screwdriver. I guess I should hold that. So the instructions say there's no reason to over tighten these. And I did see that, yeah, so this rod is still loose. I'll give it a bit more. It's set to 7, let's go up to 9. Just enough to get this rod really snug, or just to get this rod stuck in place basically. Need more. No. Come on. Something cracked. So this part down here just cracked, but we're not. This is still a bit too loose for my taste. Oh, actually, since that already cracked, let me take torque back just a tiny bit. There, okay, so now this should be, I mean, it's not like it's going anywhere. It's not like it's, yeah, like Ryan's saying, there's no load in that direction. There is load on these end brackets on the outer frame, I guess, but there's no load on this center one, and it's not sliding out. So it looks like this one is close enough. This one is tight enough. No, it's actually over there, this one. So there is a bit of a gap between these two parts. So this is the top part that we screwed on, and this is the roller that's already been on here. So I guess it's okay. It doesn't rock around or anything. It does have a bit of give, I guess, when the belt pulls, but yeah, that's good. So let's try and focus on this one. So that's the one that's next. So different motor. So here I used the old one, the Longs motor, and this is a KS42 STH 48 16A 84A. I think that's a 1.6 amp or something. Doesn't really matter. But yeah, this goes on like so, maybe. Like that. And then nut goes in the back. One there. And one there, 42 Newton, whoa, what? 42 Newton meters? What's up with that? One thing that I really, I need screws first. One thing that I really need to try, or really want to try, is servos, because you can actually get, like NEMA 17 sized all-in-one servos now. They're not super cheap, but they're like, you know, they're a system in a box. So you just buy, you just get a box that's a NEMA 7, a slightly longer NEMA 17 size. And basically you just feed it step direction signals and power, and it handles all the rest. Like it handles whether it loses position or not, it handles motor driving, it handles like pulse generation. I'm not sure if it's actually stepper motors or BLDCs, but you can get those things in a box. So I do want to try that out at some point, because it sounds really fun to just build like an overkill machine like that. Okay. So that is a bit crooked, like it looks like it's a bit tilted, but it should not matter, because this rod is defined by this lower carriage, and all this upper one is doing is holding it in place and guiding the belt. So should be good. Where have you found those servos? I can't link them right now, but I just found those on AliExpress. Actually, the NEMA 23 size is a bit cheaper than the NEMA 17. I don't know why, but it is. It is. It's a bigger motor. It gives you more torque, and it's cheaper too. So if you want to look into those, maybe that's the option to go for if you're starting from scratch. But just to like swap out the motors on some pre-existing machine and seeing if it makes a difference, or if there are any like lag issues, because servos, as far as I know, aren't as direct as steppers under some circumstances. So yeah, it might be interesting. What is the price on this? Depends on where you source it, what components you use, but somewhere in the less than $500 range. Yeah, shout out to Marco Rebs. I've been seeing that he's been doing some MPCNC stuff too. Which is validating why I'm building one. Haha. Isn't it great? Okay, I guess that's tight enough. Closed loop steppers, yes, that's also an option. I've seen some solutions with encoders on the back, and I'm pretty sure Trinamic has pretty much a plug-and-play solution for that, where you have just a little board that sits on the back of your NEMA 17. I think you just have a small magnet glued to the shaft or something, though that might be something else. But in either case, you can get driver packages or eval boards or something that screws that have all that included, including like step loss detection and all that you'd expect from a servo. Like not just what the pusher is doing with oh, I've lost something, but actual measurement and real-time correction. "14-bit encoder. Wow, that's probably more accuracy or more precision, should I say, than you're ever going to need for a stepper motor. So Ryan, you said these were the worst ones. These were actually the best ones because they're so accessible with a screwdriver. These were no problem to tighten them down at all. Let me double check. We have the pulleys on all of them. Yes. So, motors installed. So what I've actually looked or learned from the instructions is that, say I'm going to have my electronics and power supply and all that on this end. I'm back here somewhere with. Let's grab this IKEA panel again. Maybe mounted like so, just to the side, and just mount all the electronics on the outside so they're away from swarf and stuff. If I have my electronics there, this motor doesn't need to be routed all the way around. You can actually route it through the tubing so it comes out the other side here. I'm gonna have to check if I have motor cables that are long enough there, or for these ones, these are the DuPont connectors, if I have extensions that are long enough for that. But and that's how it's intended. And for this front motor as well, you just feed it through this tubing and it comes out the back over there and you route it there. I mean, it just makes for less cables, less individual cable strands hanging around. Now, because I just have these here and I'm just noticing them, yeah. I'm not quite sure which one is the one that I've reprinted, because I did have these in PLA, so I think these are actually PLA. Yeah. And this one I think is the one that I just reprinted in the ABS. In just standard black ESUN ABS. Yeah, it's getting some warping. Looks like these also have warping. I'm thinking this is the ABS one. As soon as I get this here, yeah, handy trick, pro tip while we're at it. If you grab yourself one of these blurry deburring tools, come on, there we go. Okay, You grab yourself one of these deburring tools, and on an ABS part, look at how creamy that is. Look at how smooth that swerve comes off. On a PLA part, this is also ABS. I've already reprinted these. Okay. On a PLA part, you can actually hear it jumping around. I'm hoping you can hear that, that noise. Okay, apparently I was being smart. Okay, these only work one way. Yeah, this does feel like ABS. Apparently I had already reprinted these. Nice, great, fantastic. So the black ones, I guess, are all ABS then. It's hard to tell sometimes. Right. Yeah, reason for that being, so these are the tool mounts obviously that go in here that hold the spindle. If these were a PLA, then the spindle would probably get hot enough to at least deform these, and at some point you're just going to have the spindle drop. So these are pretty much the only parts that I've printed out of ABS. Everything else is PLA. Because it's rigid, it's strong. It may creep over time, not sure, but time will tell. All right, rollers are mounted. The rails are going nowhere, and when you add the belt, it only increases the tension. So gantry, and then we do final, and then we do belts. These images could use an update because it's not, I've looked through them, I know what they are, but it's not really clear what each step is. Using the table as a straight guide, screw down any 2 feet. Okay. So any 2 feet, I will be doing the front. So I do have my markings on here. This is like 0, y-axis, x-axis. I think we're done with screws, right? Ah, not quite. We still need to mount the tool mount, but that's going to be in a second. So I will align this foot just to the corner. And I will also screw down this foot with the screws facing outward, so that we get this one really nicely stuck into the material. So, is NGen filament an option? NGen is a variant of PETG, so it's a co-polyester. So, at least I believe so. So yes, it is very much an option. Co-polyesters very definitely are a suitable option for printing machine parts. Prusa is doing it with the Mark III. They've switched to all PETG. It used to be ABS, it is now PETG. So, I mean, if they do it for tens of thousands of machines each month, then it should be good for, you know, your personal CNC. So yeah, I am using the wrong bit here. This is a Phillips head, and these are PZ heads, but do as I say, not as I do. Use the correct bits. This is kind of hard to get to as is. So. Oh yeah, something said that pre-drilling this might be a good option. But it looks like I'm getting these clamped down just fine. So maybe there. So yeah, these are flush with the outside corner. Camera, come on. Okay, these are flush with the outside corner now, and I think I'm just gonna line this one over here with the front edge as well. And if this panel saw was halfway or somewhat straight, then I should be able to align this front one as well with the just with the base. No pre. Yeah, I'm not pre-drilling. I'm just going in raw. Now there is a question going on in chat right now about using Dremels or not. So I've not used like the Dremels for this yet. But I did use the Proxon Industrial. They have a Dremel like, what are they called? Rotary tool, I guess. They have a generic rotary tool that even has like the little, I think it's a 20 millimeter clamping surface up front. But I've gone through 2 of those, and both of those just horribly destroyed themselves. The front bearings just are not great for the sorts of loads that you're seeing when milling. And yeah, those did not last very long. How can I? Yes, like that I can. Yeah, so Dremels, and also that they're kind of expensive already. Yes, they do get you higher RPM if you want that, but these I think are just so much more versatile. And also Ryan did mention some Dremels have horrible runout. These also aren't great for runout because like the way that they're assembled, this is basically a motor with this clamp on the front, but they're decent, like they're okay. And I don't know, quieter, they last longer. It's just, I think it's just a better experience. The better your router, the better your results. Well, yep, I mean, the better your everything, the better your results. But I've actually seen a video of an MPCNC cutting steel. That was from Ryan's official channel. Buddy sent me that video. I'd be impressed if I actually got this machine to cut steel. I'm not expecting it. Like I said in the intro video, like I'm not expecting this thing to cut steel. Apparently you can make it do it. But I've got my, I don't want to get my hopes up. I'd be very happy if you could, but don't think it does. At least not, I mean, I'm building this one slightly larger than the one that Ryan used in that video, I think. I think Ryan used a 2-foot version, which is 60 centimeters. I'm doing 20 centimeters more, which means more leverage on everything and, you know, longer belts and just a generally not quite as rigid machine. But I mean, if it can do it, like all I'm hoping for is aluminum. If it does aluminum with a fresh, sharp bit, then I'm very happy. Just a quick alignment. There we go. Okay, that should be close enough. We're off by like half a millimeter. Why not use a bit larger MDF base? Dude, like this is already 80 centimeters. Like this is as large as I'll go. If you can see it, it doesn't even fit on this desk anymore. Already having trouble with size. Not gonna get any bigger than this. So it feels like we're slightly out of square. So if this position is to be trusted at all, then this is a bit further forward. But let's check what the official guide here is. Measure across the center both ways. So we're just measuring that diagonally. Make the dimension as equal as you can go, and then clamp down the feet before you screw them down. Pre-drilling really helps. I'm clamping. Not drilling.
I hope you hang this on the wall. That would give cool video shots with the chips falling forward.
Yeah, that would be awesome. I've actually thought about just putting it back here somewhere. It's just that I'd have to build some sort of an enclosure for it. Just some acrylic window frame. I don't know, just use an IKEA lac. Those come with doors, right? I don't know. I'll have to figure something out. First, I'll have to figure out how I actually measure this. But thank you, Skipper, for the €5. Much appreciated. I guess like that, like that. So if I just bump it up against this edge right there and measure roughly to the other edge over here, that is 98.3. So if you go the other way, we're at 98.7. So this, yeah, as expected. So I'm actually feeling that On this edge, this part is a bit too far forward, like it's sticking out past this lip. So if I actually move it back here, and you can see the frame is wanting to resist. There we go. If I move it back here, back into where it should be, and measure again now, we're at 98.5 and 98.5. Perfect. So that is perfectly on point. Very nice. Clamp it soon, or the measurement won't matter. I'll measure it. I'll measure it. I'll clamp it. There we go. So the thing that I'm taking from this is that this MDF base, because I got it cut at Obi in my case, which is a home improvement store, their panel saw apparently is very square. It does cut very square, and I did notice that on previous panels that I got from them, that their cuts were always, I mean, not only do they cut very accurately, like the dimensions that I give them are always on point, but it's also square. So yeah, that is that's a good tip that I can give. Get your panels cut at an Obi or any other store. I'm not affiliated with them. So just rotated this. I'm hoping it doesn't disturb. Oh, I rotated it the wrong way. Cool. I'm hoping it doesn't disturb the squareness, but I'll just align it with the front edge again. And there we go. So just getting it roughly vertical. Looks like it needs to go a bit further inwards, but it's going to pull itself into position. Measure again. It's fine. It's fine. You guys have seen what the measurement process looks like, and I can always adjust it. We are close enough to perfect where I actually trust this to stay square. Are NEMA 23s overkill? Will 17s be fine for aluminum or brass milling? So I've not run this machine yet. I feel like with a small bit, like with your regular 1/8 inch bit, which is the one that you will probably be using in this machine, NEMA 17s should be fine. Like they should be okay. 23s, unless you really drive them hard and unless you really give them a ton of current with good drivers, like just adding current doesn't matter if your drivers are just doing nothing properly, then yeah, I mean, NEMA, you can use NEMA 23s, but I don't really think it's necessary. Like it's still a machine that's using printed parts. So by the way, there's no way I can show you this. I need like a head-mounted or helmet-mounted cam. This now also lines up perfectly. There's like a 3.5 millimeter gap equally around both sides. So that tells me that we did something wrong with the squaring. It's weird when you rotate your base and all of a sudden your parts are in a totally in totally wrong spot. How overkill would a 1 kilowatt spindle be for this? Here's the thing. We are not... I've got the base. That's how I want it. We're not that far off from a kilowatt. Like this spindle is 500 watts, I believe. So they're saying 500 watts, brushless, air-cooled spindle. The 1 kilowatt ones are just, I mean, they have much nicer drivers, I think. And they're also typically water-cooled. It's probably overkill. Like the one advantage that I see is getting higher RPM. And that's going to be a really good thing for a small tool like the 1/8 inch tools. My spindle only goes up to 12,000 RPM, which I think is not enough. Not quite to do decent cutting speeds. Dremels or the Makita routers or those sort of tools go up to 30,000 at times, and that obviously lets you munch through material much quicker and gets you closer to the ideal cutting parameters. I mean, that's an advantage you get with the trim routers and the Dremels and possibly the 1 kilowatt tools, but I actually much prefer the experience of having that brushless spindle versus a trim router or, you know, a big 1 kilowatt spindle. I mean, they're not that expensive, interestingly, but I don't think you need it for this sort of a machine. Somebody asked whether they should go with a brushed or a brushless spindle kit or spindle version, because you can get these sort of like spindle motor typey doodads in both brushed and brushless. I have the brushed version on the Mendelmax CNC, which has been holding up really well. It's been serving me well. I'm trying the brushless one here. I don't know if it's going to have advantages for longevity or noise. I think it's a bit less noisy than the brushed one. I'm also hoping that it's going to have more torque at lower RPM, because the driver actually has RPM control, and for the brushed one all you do is you lower the power supply voltage. So that may be an advantage with the brushless one. I think it's just the better option. Yes, it's like 20 bucks more expensive to go with the brushless version, but if it has just a tiny leg up in like low RPM torque, then I think that is already worth it. So should we measure again and see how far off we booped it? Let's see. So I still need to adjust the height, but yeah, 98.5, perfectly on point. Nice. Are your XY axis motors the same for the same axis? Yes, they are. I checked, they are. So they're different motors on the X and on the Y, but for the Y axis they're the same motors, and for the X axis they're the same motors. So yes. Right, next up, we will be adjusting the height. So I'm hoping we're not going to be cutting parallelograms. Let's make sure we also have the height correct. Now, technically, so I mean, these can still, I guess these could still move up and down. So you could have the entire frame crooked on the bed. But, well, what you can do with a CNC, obviously, is you can mill your bed flat. And it's something that most CNC users do as like the very first thing they do. I mean, it's a bit tedious with a bed this large, but you could do that. So you technically you wouldn't have to adjust this totally perfectly, but I'll try to get it close. I'll try to get it somewhat close at least. Now, set all the legs to the same height. Now, what you need to do here is, I guess, to set these all to the same height, I'll measure uptime. Is Nightbot not active? Or can, I think Nightbot is just limited for who can actually use them. What I'll do is I'll measure up to where? Right, these are all at the same height, okay. I will measure up to the transition between, here, you guys can actually watch, because we do have cameras. I'll measure up to the height of the yellow-red transition right there. So this one is 11.85 or something. And obviously I can't lower these down because these tube sections do have, you know, they do have a length to them, and some of them are, or most of them are actually sitting on just the tube end on the corners. So I'll need to pick the longest dimension here. What did I say here? 11.85. 11.7, so far 11.85. 11.85, I guess these two I can just clamp down. The last one is not longer. Shouldn't you measure to the bottom of the spindle mount? What? Calipers are great for this? Yeah, I've got my calipers upstairs. This is 11.75, so These two diagonally I can already clamp down because they are the tallest ones and they are identical. And of course, if you've cut these tubing sections to the perfect size, to the perfect dimension, then yeah, you're good. You don't have to adjust anything. But I did this on like one of those big cutoff 355mm cutoff disc thingies. Miter. It's a miter saw with a cutting wheel, and that thing doesn't cut very precisely, very accurately. Very precise. I can never remember which is which. But this needs to get clamped down. So both the one at the bottom and the one at the top. You can see this nut is still totally loose. That's going to be fun to tighten because there's not much room to jam a screwdriver in there. But let's try. Hello from the UK. Hello back to the UK. Chat is going by way too fast. Where did I put where did my 3mm go? Where did I put my 3mm? Probably pushed it off the table at some point. Thankfully I do have a backup. So, these get tightened down. Again, I'm on around 12 torque setting, 12 torques. And that feels good. Ooh, fly cutter. Who's bringing up the fly cutter? Sebastian is bringing up the fly cutter. Like, if you don't know the fly cutter, watch what a fly cutter is, watch this whole Tony video on it, obviously. But a fly cutter is basically a cutter that is mounted somewhere here, and then extends from the spindle, and it just spins like that. And it has a cutter on the end and just like chops off or chops away at the base like that. I don't know. I don't think they're that scary or more scary than other types of cutters because like you reach into a cutter, your finger's gone in most cases. And a fly cutter, it spins so fast, you're not going to get it in there that much anyway. So I don't know. But a fly cutter is probably not what this machine is going to be using. At least I think. So this one needs to be shimmed up. And this one back here can get tightened down. So 11 point, yes. All right. Oh, wrong side. There and there. Okay, that's tight. There are quite some small fly cutters. Oh, that is nice. Where can I get those, and what search terms would I need to use to find them? For sleeves for height adjustment, yeah. I mean, I guess we could do that, but it's much easier to just adjust them on the go. Now, one thing that I do want to try is I've used this clamp before, which is just a one-hand wood clamp. What you can do with these is you can take off the non-moving end, grab the correct Torx bit, and you can move that to the other side. So making some space here. You remove that, and then you plop it on back here, and then you get that screw back in, and get the nut back in. And now, instead of having a clamp that pulls together, you now have a clamp that pushes. So I will try I will try to find a position where I can actually jack this post up. So which ones did I tighten? I tightened the one at 0 over there, and I tightened the one over here. So now I need this one. I'm guessing I can just jack up this. Let's jack up the entire table. What do we say? 11.75. 8.5, sorry. That's interesting. This one is... Oh, no, it's coming. Okay. I'll use my tappy adjustment hammer and make sure there's no tension in these parts, that it's not like crooked and all tensed up. And then we can tap it back down into position. Well, actually, we need to go a bit further up. Too much precision might kill the build. This thing is 100% guesswork based. I mean, I like the amount of... There's my 3mm. I like the amount of adjustability that the build has, even though it's not like, you know, you have an adjustment screw for the height of each of these legs. Like, it's really just you clamp it down in the correct position. Hello? There we go. But yeah, you can adjust for, you know, tubing that wasn't cut to the right length, or, you know, printed parts that are crooked, or all that. So let me double check if we are at the right height. 11.85, yes! Now last one. Is there a version with more space for a ratchet or a spanner? I don't think there is. That and this one. Yeah, the screw jamminess is not not the greatest feature of this build. I mean, once you get the hang of it, it's okay, but I'd rather not have to do it. So we're at 7.5. There's not even a metric version. Well, there are some parts that are specific in metric. Like, I think the tool mount is a specifically metric version, but the rest of the parts are universal, where it's either some imperial size screw or the metric M4s. And I guess some 8s too. But yeah, there's no specifically metric made version of this machine, or fully metric machine. All right, so all hail software alignment. Yeah, I guess you could put just a Beal touch on this and probe the build surface before you go, or before you mill it down. For squareness, you need some sort of precisely manufactured base in this, and I think that would drive cost through the roof. Just having an 80 by 80 PCB with just the something cracked with just the probe points in there would be fun, but yeah, Beal touch would get rattled. Probably, yeah. Maybe use a capacitive sensor or something. So motors are on. Man, it just cracked again. I think that end over there is kind of giving up. Might be the foot, but as long as it's holding up, as long as it's not scratching down, it's settling. Yes, it is settling. You're right about that. Where are my nuts? Did I get rid of my nuts? There they are. Okay, it's starting to look like a machine. It's starting to look like a CNC. And if we imagine we have some sort of, this clamp, by the way, looks absolutely tiny on the work surface. It looks so out of place. It looks so completely ridiculous, but this is how large is this? 75 millimeter wide. I think it also opens like 60 or 75 millimeters. So it's a super cheap clamp. These are like $10 or so, but this is what I expect to be holding parts with. It's like, yeah, fun. All right. By the way, I really like the way that YouTube is highlighting YouTube members in chat. So Steven and Foxy Bill, hi guys, good to have you back. All right, screen cap. So we have adjusted the height. We've done that. I've heard people really like the noise of other people drinking and eating. Water. Be careful with your legs. Be careful with your leg cuts. This can be an easy step. Okay, running the wires. Decide where your control board will be located. Make sure the belt will have a clear path, and then connect the closest stepper to the plug in the middle of the harness with a stepper. Harness? Okay, I guess you can get a pre-made harness. I don't have a harness. I will be plugging in stuff manually, the old school way. I think the Do-It has, I've not removed the Do-It from my printer yet, but the Do-It has dual ZZ motors, which is exactly not what we need, but I think we can reconfigure that, if I'm not entirely mistaken. So we just need to make one splitter for this entire machine. Let me get this aligned correctly again. Why is this bouncing off? Did it go through? No. No, the space is just... Oh, that's the noise I was hearing. Okay. 0 point back where it should be. Wires. Yes, wires. Now, I do have a big old box of wires that I have. Marek is asking, do I plan to install drag chains? I do not plan on installing drag chains right now, but it could be an option at some point. So this is the 14-piece wrap cable set that you can get for like $2 or $3. What I'm noticing is that it's rather short. So I think this is 75 or 70 centimeters. That won't even make it through a single length of tubing. So that can work for like the, maybe for this one over here. If I have the electronics back here, then that can work for that. But I do also have longer ones. I did specifically order these. And you can also see these are just stepper motors, longer ones. Let me see what I do have here. These are short. These are also just 80. Damn it. That's no good. Okay, that's too short, that's too short. Now, let's check these guys. Because I did also order some 2-meter ones. That's looking better. That's a 1-meter type. Still too short though. Okay, that's more like it. That's 1.50 meters or so. That's the length of stepper cord that I need. All right, and these are, the thing is, these are terminated to the same sort of connector. They'll fit on the they'll fit into the standard 4-pin plugs. So, you know, this is the motor side with the 6 pins and then the 4 pins on this end. It's not the standard like 4-pin. These are a bit thinner than the DuPont connectors. Then I just dropped those behind me somewhere, but they'll most likely still fit on most boards. So that's what I'm going to use on at least 2 of them. Or maybe I'm actually just going to rewire them at some other point. maybe I think that's the smarter choice for now. We will come back to the wiring and the electronics, I think, on Saturday actually. So let's finish off the mechanics first. Let's mount the spindle. What time is it? 8:04. Let's see if we can mount the spindle today, or if we can. Well, we'll definitely do the belt, and then let's see if we can get to the spindle as well, because that should be a rather quick job. So skipping wiring for now. I'll have to figure that out at some point. Don't want to figure that out live on stream. I think it's kind of boring to watch me go through wiring. But take note, if you're building a large machine, you're going to need long wiring. It seems logical, right? Belts. Let's do belts. Move the gantry all the way to the lower left corner. Wait, what is lower left? So I guess that's X0, Y0. Paying attention to which the cable tie heads are facing for that slick, clean look. So this is apparently how the belts are mounted. Kind of reminds me of the printer board way. Oh, did I actually grab some zip ties? I do still need to grab some zip ties. But printer board ways, we have one zip tie going through these parts. So this one's very red, so you can barely see it, but one zip tie going through here, then making a loop and looping through the belt, and then another zip tie clamping the belt shut around that. So I believe that's just what we're going to be doing. Loop the next tie through the belt loop and the corner piece. Leave this one as loose as possible with adjustment. Okay. I believe that's just what we're going to be doing on 1, 2, 3, 4 sides. Zip tie tension is commonly replaced with a printed tensioner of Thingiverse. I guess you can always replace parts with other parts that are slightly upgraded. I'm going to be back in 15 seconds.
Shout out to the V1 Engineering Forums. Fun build.
Found it. Wasn't quite 15 seconds because this box of zip ties was not exactly where I was looking for it. It was under one of the C-stands in this studio. It wasn't over in the workshop. Go figure. What did I miss in chat here? 40. Okay, I've not really done 15 seconds. I did miss a super chat from Jeff Abel. Shout out to the V1 engineering forums, fun build. Yes, shout out to any sort of forum that supports users in their endeavors of building machines, improving their skills, or printers, or anything like that. Forums are great. I also run a forum. I should probably pay more attention to that. But yeah, let me double check. These zip ties are too big. That size, no good. Oh yeah, but $2 doesn't have text-to-speech. Teardown of the spindle brushed head flaws fixed now. I don't know what exactly were the flaws with or what flaws the brushed spindle has. I've been pretty happy with mine, but I don't actually want to tear down. Don't want to tear down the spindle because I don't know if I'm gonna get it back together. It just has, I mean, there's not much to a brushless spindle, right? There are two bearings. There's an outer coil pack and a rotor with a magnet. It's like, there's not much to it. So yes, zip ties. These are the 2.5 by 100 size. These are relatively cheap zip ties. I'm hoping these are holding up. But the shoe fits. I guess a 3mm zip tie could fit. Are these slightly wider? No. These maybe? These? Yeah, that's the size. That's the one that you want. So I believe that's a 3mm. I think I just have barely enough of them. These go through like that, and then they loop around the belt. So, belt. The belt. Where did we have the belt? That sounds so familiar. Was that, what was the belt? Anyone remember? Okay, brushed has rubber seats for bearings. Wow, okay, belt was the Mark III. You're right. So I have two belts here. They look identical. This one's a bit slightly shinier. LI2GT6. This one's unmarked. I feel like this one's actually the nicer belt. Not sure. I will try and use that because a belt that comes just in a loose package, I don't trust as much as one that comes in a nice coil. So this one came nicely coiled up, though I have already messed that up. I'll use that one. So that was my... No, I've got those out here. But we do still need zip ties to zip tie the belt together. Actually, we'll use the larger ones for that. We don't need to go with the small ones. We'll use these. Okay. Isn't LL2GT the Gates belt? I guess they're just labeling it by the names that Gates is using. This is actually, no, this is LI2GT. I guess trademarks and stuff, right? So, belt length. Now, the belt length here, I'm guessing is you can measure these, you can pre-cut them, but I'm just going to zip tie them together and cut them to length. So orientation is correct because we do need this to be able to, why do I need to have this in the home position? This runs through like so, and then up and over and back. So under these bearings and then back. I'll just route it through how it needs to be, and then I'll start trimming it to size. I actually don't want it to go through this tubing. Won't the belt stretch when cutting harder materials? Yeah, for sure, definitely. But I mean, how much is it actually going to stretch, and how much are you going to be cutting quote unquote harder materials with it? How much does it actually matter? Probably not that much, if I'm honest. Belts are probably one of the, at least if you're using decent belts. Like these belts are just cheaper ones. I'm not sure how good they are, but the Gates belts are surprisingly stiff. If you get like genuine belts, it does make a real difference. So leave about, how much? An inch? Yeah, that much for adjustment. And then this belt is tightened down. Trim the cable ends. I'll do that once we're done. Cable tie ends, I'll do that once we're done. Better use fiberglass instead. Well, these are fiberglass. Though I think we touched on that in one of the build streams. And there are 2 belts per axis. What? Yeah, there are 2 belts per axis. That I was just wondering about it. Like, am I supposed to double these up? No, there's 1 belt on one side and 1 on the other. So these are symmetrically driven. You can buy steel reinforced on AliExpress. That was one thing that came up in one of the streams before this one. And yes, you can buy steel reinforced on AliExpress, but apparently, I mean, I do have a set of those here, but apparently, especially when you're using these smaller pulleys, they do like to work hard and they do like to break over time, much more than fiberglass, which is inherently more elastic or more bendy. So I need 1 zip tie through here. Let's all do these the same way. So with the head going in like that. And then let's cut them somewhere around here, or let's zip tie them down first. Can you cut aluminum with this MPCNC, or is it wood only? Now, like I said in the intro video, I do expect to. I'm hoping for aluminum. I'm hoping that it does aluminum. So far, I'm confident that it does aluminum, but I can't guarantee that it does aluminum yet. Apparently, it can even do steel, though that may be for the smaller versions only. I do have a relatively large MPCNC. There we go. So I'm happy with aluminum. Aluminum at this size is good anyways. Like cutting a 50 by 50 centimeter chunk of aluminum is something that will make me happy. I can guarantee you that much. So this is still somewhat floppy and somewhat loose. Yeah, there we go. And yeah, this will settle over time, and I may need to replace these zip ties because they're not great. Apparently there are printable, wow. Okay. Apparently there are printable belt tensioners. I do like harder belt tensioners more than I like these like soft ones. So ones that you can actually adjust with a screw that physically push the belt out by that screw tension. But, well, we'll see. I'll try this stock first. As with any machine, I'll try it stock, unmodified first, and then we can see what actually needs modifying and what is good as is. Evan is saying a friend of hers is or has cut stainless on this machine already, which is, whew. I mean, stainless is hard to cut simply because stainless does not transfer heat particularly well away from the from your cutting area, so it does like to overheat. It's also one of the reasons why like titanium is so tricky to cut, because heat is a huge issue. But yeah, that's even more of an achievement then. Oh, this zip tie is no good. So yeah, a good idea is to double up these zip ties on the belt loops. Definitely. I think even Printable had done that, where it was like, okay, add a second zip tie. And I will do that once this thing is running. First, I'll get it to that point, right? I guess I should have started on the other end. Thankfully, belt is cheap and I can always cut it twice. Should you not feed the belt in first? Yeah, I should. There's that. That is running. And then we make our loop. Does it depend a lot on the spindle, what material it can cut? So my experience with the CNC machines so far, which were all like really light duty, really, let me say, flimsy CNCs, is the spindle actually does not matter a whole lot. The spindle, the spindle is just that last bit. And yeah, if you get a good spindle that has low runout, like that's going to be a huge advantage. But you're most likely not going to run out of spindle power. Like the spindle power that you have should be the last bit that you worry about. You should worry about getting a rigid machine first, getting your cut parameters tuned in, using good bits, using appropriate cooling, all that before you worry about spindle power. Now, RPM can be a thing. RPM can be a big factor. You can work around a lower RPM spindle like I'm using here with the 12K RPM. But like in my experience, spindle power really didn't matter. So yeah, air turbine spindle motor. Possibly if you want to do like high-speed cutting. Right. Yeah, I'll clean up the zip ties once we're done here. $12K RPM can even do PCBs correctly. I mean, the thing is the type of PCBs or the type of cutters you use for PCBs are very, very small. So you do need a very high RPM. Thank you for the 2 years, Martin. I will definitely get me some good coffee. But I'm not wasting my money on Starbucks. I'm making that myself. What mic am I using for this stream? Gear of this live stream and regular YouTube videos and all that stuff is linked in the description below. toms3d.org/my-gear. I'm using the Rode Filmmaker kit, the same mic that I always use. It is plugged in straight into my camera, which feeds into a Blackmagic Decklink Quad HDMI recorder, and that carries the audio signal with it. So yeah, Rode Filmmaker kit, wireless, very, very convenient. I got these sets actually for live streaming most of all, because I can move around. I would be happy with recording with a smart lav, but live, that's just not an option because you're just recording into your phone. You're not going to get that live streamed. Why did I choose the China spindle over DeWalt? I did choose the China spindle, or brushless DC motor to be like more accurate there, over DeWalt or Makita or something, because two things: noise, first of all. I do have one of the Makita spindles on the. I did have the Makita spindle on the CNC, and it's just been super noisy and vibrating and stuff. And also choices of tool mounts. So the Makita spindle has a proprietary collet size that is very expensive to get extra collets for, that are not just a standard 6mm and 1/4 inch size. Like it's going to cost as much as the spindle itself, basically, or the trim router itself, to get a new collet size. And this spindle is just a standard ER11. And collets for that are super cheap and super available. And also it's smaller, it's less noisy, it's just more convenient.
There you go, Tom, for Starbucks coffee.
Starbucks coffee. I'm not spending that on Starbucks. I'll find a nice artisan coffee shop and get myself a straight double espresso. But thank you, Arik, and thank you, Anti, for the $2. Swap the top corner pieces to black and it's a flag. What flag would that be then? What? The top corner pieces, these. What flag is yellow, black, blue, red? Is that like a South African color theme or something? I don't know, man. It's way too colorful to be any sort of a decent flag, I think. If anyone knows a flag that has the, I mean, black, red, gold, yeah, Germany, obviously, but we have too much blue in here. I mean, the entire centerpiece is blue, like yellow, red, and black. I guess that works too. What is the machine behind me with the cable chains? That guy, Mendel 9000 test platform, that used to be, that's actually, you know, an incremental upgrade over, or a step-by-step upgrade for my very first machine, which was a Prusa Mendel V2. Not the Mark II, the V2. And that has the Do-It in it, and is my modular swappy platform that I need to get working at some point, like fully qualified. Blue is for Bavaria, I guess. Belgium? What is the Belgium? The Belgian flag is, it's the same, right? It's just different orientation. All right, last one. And then we finally get to trim all these zip tie heads. Okay, why is this one too large? Did I? Oh, that's the one that's printed on draft settings with no cooling. So I guess that is to be expected to be slightly tight. So there, and there, and there. Belgian flag has yellow in the middle, yeah. I guessed as much. Okay, let's get all of these slightly. I should have picked a small machine. Let's get all these tightened up. I guess they don't need to be like super duper tight, but I'll tune them by ear as I usually do. It's probably too tight, but it's good. That's good, that's good. Let's give it a bit more. Black, red, gold. Yeah, I could have done. I could have used some gold happens or something. But I tend to leave nationalism and politics and all that stuff out of my videos. So, yeah. I gotta say that is extremely satisfying. Snipping off zip tie heads. So good. So clean now. And I guess I do need to cut this one off as well. So there's my last one. Looks to me like you put all the zip ties on wrong. How do you put a zip tie on wrong? Oh, this one. That's the problem with these cheap zip ties. They don't hold all that well. Let's use a good one for this side. Yeah, so that double loop zip tie assembly, I guess it would have been possible to use at least like proper clamping on one side, or just that slot in push in version that for example Prusa does, where you just slide the belt in sideways into a matching profile into your part, and that just clamps it down like that, or holds it in place, to be exact. But I mean, this kind of works. You're still going to have the zip tie tensioning on one side either way, unless you have like I don't know. I'm sure tensioning could be solved differently, but then again, coming back to Prusa doesn't have any tensioning on the x-axis at all. Like it's just mounted on the tension. That's it. Okie dokie. There is our machine mechanically mostly finished. Let's see how well these. Oh. Okay, that feels interesting. That feels different. It is smooth, yeah, it is still very smooth, but there's noticeable friction from the motors. Like I'm sure as soon as they Mark III has x-axis. Oh yes, right, the Mark III has it in one of the ends somewhere. Is this like Core XY? I'll get to that in a second. Yeah, it's noticeably not quite as smooth anymore because there is that resistance from the motors, but obviously it's two stepper motors that are generating that drag. But it's feeling good. It's you know, you can move it throughout its entire motion range with no hiccups. Unless you actually have it chew up your t-shirt. But no, this is not a Core XY. This is just a standard XY drive. Core XY would have a belt going across the top and then back and like that, sort of. Way more beltage on a Core XY, which would not be great on a CNC with belts that are already kind of long, because you'd get even more wobbliness in that setup. And you know, with long belts, you also get back that racking effect that Core XY is trying to avoid. Make sure the roller bearings do not hit belt loop. Blah, blah, blah. Trim the belt. Yeah. I have no way to quantify belt tension without a special tool. Yeah, it's tightened. It's good. Please trim the cable ties. We did that. So for our last trick today, we will be doing, well, we're done, I guess, except for wiring. We will be assembling, installing the spindle. So, spindle. Now this spindle came with a full kit. So it did come with this clamp, which just clamps onto some sort of a flat surface on this side and then opens up like that, which I'll not be using because we don't have a flat surface to screw it to. So, nope, not doing that. And then we have the spindle itself. So this is the air-cooled brushless spindle, what should I call it? Basically all this is a brushless motor with this sort of fan disc on the end. You know, this is just directly connected to the shaft. It is brushless, yes, it's the brushless version. And then on the 10 or 8 millimeter shaft on the front, there's this collet chuck kind of adapter that adapts the motor shaft to an ER11 collet. You can actually see it's clamped down with grub screws onto the motor shaft, so it's not like an integral part of the spindle. You can get actually somewhat nicer spindles that run off of the same drivers with a much larger shaft, where the shaft itself is the collet holder. So yeah, this is a 400 watt spindle. So the 500 watt ones are slightly longer, but they are the exact same 55 millimeter size. I don't think like it's gonna make much of a difference, because we're not going to be loading this to its full capacity. We're not going to be loading this with 500 watts of cutting force. At least I'm not planning to. I may accidentally do that. Then that set did include, oh, I don't want to rip that out. The set did include this driver. This is a WS55180, so same part number as the motor. BLDC motor driver. This is kind of like just a universal motor driver, I guess. So you get control with RPM. There's a plus 10 volt control signal. I guess you can control it with that somehow as well. But there's the, let me actually see how that's wired up. So I'm guessing that's a positive, ground, enable. So enable is just pulled to ground. So yeah, if someone wants to decode that, you might guess. There's also the switch connected, which is not on off. It may look like it's on off, but it's actually forward and reverse. So you can see FR, it's forward, reverse on the driver. So you can run the spindle backwards, which is like absolutely useless on a cutter. And yeah, you also get this RPM viewy thingy display. So that's a 6-digit RPM display that actually displays RPM in just numbers. So yeah, that's what I'm using. So the driver is going to go with the electronics. And then also it included a power supply, but this is just a standard 48 volt power supply, 12 amp, which means it's a good bit oversized for what it's doing. I think that was included. But for now, we just need the motor itself. The plus 10 is probably PWM speed control. It would be nice. It's probably internally smooth anyways. But yeah. Stay. I'm sure there's some way to, because I mean, it's just a potentiometer. I'm sure there's some way you can just give it some value, either that's PWM or a voltage signal, and control RPM through software, through your main board. Maybe 0 to 10 volts is not going to be something a 5 volt or a 3.3 volt can output, but you can definitely work with, I don't know, if it's PWM level shifters or something along those lines, to get that signal suitable for that driver. But there's definitely a way to control it. We're just with the transistor, the single one. That also works. So I'm thinking about how I can show you this mountage. I guess like that. So if we screw this back upwards. There you go. So that is part of the MPCNC here. So that's connected to the Z-axis rods. And then I printed these two parts off of Thingiverse. I guess you can just use one, but I printed two. And these fit on here and then screw down into these parts. There are nuts glued into the back there. Whew, that is quite tight with these screws here. There you go. So ER16, no, it's an ER11 on this one. So how high can I or should I go with this? I'm thinking as high up as I can, because we do have enough motion to go down. So I'm thinking like here, roughly, right? That looks good. So we just have like a centimeter or a centimeter and a half where the collet extends past the bottom of these tubes, and then we always have the extension of the cutter itself. So yeah, let's just try that. I don't think I want to go all the way down. Nah, that doesn't seem right. Let's go here and here. That's just a bit further down. Right there. Down or up? Let me know. Up, down. If someone posts the Konami code, I'll just put mounts all over this thing. Up, 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 up. Call it close to flush with the bottom. Okay, that means up. That nut is not gripping. That's fantastic because there's absolutely no way to get to it. This one's gripping. No, this one's also turning loose. Am I using... Are these long enough? Lower the axis, then make sure the spindle touches the ground. Yeah, we got that. Oh, these screws are actually slightly too short, it seems. But they're not going to pull out. I'm going to grab some longer ones. Grab some 25s. Glue the nuts in place. The nuts are glued in place, definitely. Maybe rotate the upper one 180 degrees. The thing is, I've tried that, but the clamping surface, I think, on the motor is not actually long enough for that. So this what's it called? Pack of sheet plates is not long enough to allow me to rotate this one upwards. Oh yeah, that feels better. That feels much better. There we go. That one's actually gripping. So let's replace these as well. Yeah, €11.75 for 15 different sizes. That's ER11 collets, right? Yeah, again, like that was one of the main reasons why I went for this with the ER11 versus something like the Makita router, because with the Makita router, you do have to get like either adapters, and adapters are horrible for runout and all that, or have like a custom handcrafted collet, which would be like 50 or 60 bucks shipped, and that's just, I mean, that's just not worth it. All right, so that goes in here. So the collet is extending about half an inch. I guess half an inch is the closest approximation of that dimension. What does this get? So there are no... There's nothing that would grab the screws here, so I'm thinking they want me to use a nut with that, which also needs the long screws. Hoping I have enough of these. Just barely. Did I say where I got what? Did that spindle come with the kit? So yes, I am not using the kit. I did self-source this machine completely completely from scratch. You can get the kit off of V1, the V1 engineering kit. You can get that, but I don't think it includes the spindle. The spindle is always kind of optional, but yeah, you can use pretty much whichever spindle you want with this set, or with whatever build, either self-sourced or as a kit. Hoping these are long enough. So as you just saw, we can always adjust the height of these, adjust the focus. The camera does what it wants. Actually, it's holding up just fine as is, with no nuts on the back. Where's the clearance now? I could show you, but I'd have to lift this machine, which is kind of heavy. There we go. That's what it looks right now. Looks like right now. Air-cooled spindle is going to be loud. This one actually not. I've tried it, and we can actually try and turn it on in a second. It should be relatively easy to plug in. These are not very loud. I mean, it might resonate just in the entire assembly, because steel tubing and stuff obviously doesn't have much dampening to it. But noise-wise, this is actually not that bad. At least from what I've tried, just running it on my desk and stuff. Clearance to the bearing? Which bearing? Where's the airflow? There's no fins. That is correct. There are no fins on this spindle. The only airflow that it's getting is basically from this thing kind of spewing out through this slot. So it's just blowing lightly over this entire assembly. So this aluminum end cap is probably what's doing the majority of the cooling for this one. Cutting noise will be much louder anyways. Yeah, and probably the compressor that's going to be blowing coolant and all that, though coolant with an MDF base might not be the smartest choice. Clearance of the bearing. Yeah, I mean, back here it looks good with the bearing and all that. So, whew. Well, we're going to screw this one straight into that area. Maybe down there you can see that. That is the top nut. That is quite close. There's like a millimeter of space between the bearing and the screw sticking out. Why is everything so tight? Why? We'll be filling the steel conduit with any material to get reducing resonance, improve the finish quality. I've thought about it. So apparently there are some... sorry, I need to concentrate real quick here. No. Apparently there is the idea that you can fill these with concrete and I guess make them stiffer at the same time, which I don't think really does much. Yeah, there. I've thought about filling it with sand actually, so maybe these cross beams, but they're moving, so yeah, probably don't want to add too much weight. Maybe the outside ones, maybe just fill those with, hold on. Maybe just fill those with sand so that you get less resonance, get some dampening in these tubes. But yeah, like not the moving ones for sure, but maybe these outside ones. I'm not sure how much that is actually going to do. Like I feel like it's not going to be a huge difference. Because for dampening the plastic parts already, they should already dampen quite a bit. Fill it with candy. Yeah, that's fantastic. I'm going to say that just snapped into place, right? That's why we have two. Yeah, that's why we have two mounts. And we are... I'll undo this ever so slightly because it looks like we're touching the bearing, but we're probably not. Yeah, that's better. Let's tighten up the other side a bit more to make up for that. There you go. So now we have a spindle that is turning. Am I using nylock nuts? Am I using nylock nuts for the clamps? Yes, I am. So this might actually be too short as well, because when we're down here, ooh, barely. I'm guessing there's no way to route this through some sort of a tube, but because it's always moving around, right? So yeah, I'm probably gonna have to extend these, but these are easy to extend. Give it a wiggle, for sure. Wiggle, 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 wiggle. I mean, you can't, but I can see it. So, wiggle, 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 wiggle. You can see the Z-axis pillar is kind of skewing. But that might just be these bearings that need a bit more tightening. We'll see. We'll see. Fit some drag chains. eventually. I want to get it cutting first and then, you know, see if I have to or want to modify it. So the last thing I guess we can do today is give the spindle a test drive and see what it does right now. So you guys apparently do want to see how loud it is, and I want to see that as well. So, power supply, nice unlabeled wiring with no crimped ends. That is always great. I'm just hoping that I'll plug this in the right way around. So this driver has two removable connectors. So one's here. This one's for all the controls and stuff. And then one higher power one that already has the spindle wired in. And UVW, that's the 3 phases of the motor, and then positive and negative. Let me actually fully split up this wire so it don't accidentally mix up positive and negative. That would be bad. So that's positive. That goes in over here, and these are clamps that you can just jam the raw wire into. There we go. And then negative. Anonym is asking, do you think you can build a 1-inch tube MPCNC with a 2-meter workspace? I mean, 1-inch tube, it's probably not enough. I'd go with something a bit larger, or preferably more massive beam, something that's supported, like supported rails, is most likely the smarter choice for something that big, because you will get a lot of resonance and a lot of just flex in the entire thing. So, okay, this is high voltage. This is 220 volts now. As soon as I plug it in, let's plug it in. So somebody just pointed out, do not operate the forward reverse switch while it is, oh yeah, 1-inch tubing, you're right. This is basically 1-inch tubing. Good point. Inches make no sense to me. Right, let's. There, can you guys see anything on that? I guess I'll get you the spindle end as well. There's the spindle. So this is somewhere min-max. I don't know. Let's just plug it in. You guys ready? This might be, yeah, headphone users prepare. This might be loud. I think it's not loud, but might be. We're getting fan noise from the power supply. Tighten the chuck. Yeah, I don't want that to fly off, but it's tight enough. It's tight enough. It's tight enough. Take the forward reverse switch off if you don't ever use reverse. So let's, yeah, so this is on 0. You guys can probably see that. I don't know. I don't think that's all that loud. There is a very noticeable, oh, God, that's going to be really annoying. There's like a 15 kilohertz whine to it, because I'm thinking this thing runs at like 15 kilohertz or something internally, but like the actual motor noise is not bad, but there's just that drive noise now. And of course the display is working as well. So that's roughly a 12K, but it is actually relatively quiet. Now, of course, I have the microphone fairly close to me. I have the microphone right there, so it's much closer to my mic than, or to my mouth than to the spindle. If we kind of equal out the distances, so that I'm like right next to it, it is obviously louder. But it's not bad. Like, it's what I like about the spindle. The high-pitched noise I've not noticed before, though. But, okay. Yeah, Stefan has actually recently complained about all that 15 kilohertz or 17, 19 kilohertz noise that is going on in Tokyo, where people apparently use that to deter, like, rats and stuff. and he's constantly hearing it. It would drive me mad, but yeah. Can I? You're gonna use ear protection anyways. Yes, and hearing protection, actually, these are painted 3M Peltor, like the thinner ones. These actually filter out high frequency really well, and I've used that with some printers that have high frequency issues. But the yeah, someone was pointing out the motors are going to do that as well. Depends on the combination of motors and drivers. Allegros don't tend to do it, but Trinamics with the wrong motors and DRVs on almost all motors do have that high pitch noise as well. I'll have to see how annoying this actually is. Now, for the question on whether I can stop this spindle by hand, I have tried that. I've burned my hand. Do not recommend. So I've tried to stop it up here on the cooling fan tower thing, but that's painful. Like, don't try it. These things do have quite a lot of torque. I can try on like the lower speed setting, like if I just barely give it some juice. So like 1,000 RPM. Yeah, I can somewhat easily stop it, but you can actually feel that, you know, oh, it just shut off. Okay, it noticed that something was wrong. That's good. But I can feel it actually cranking up the torque as I try to grip down on it. So if I reset this and respin it, yeah. It's like 2,500 now. I can stop it by hand, but it does have some torque. It's probably because I have a lot of leverage on this bigger one, but we're gonna have to see how well it does for cutting. Now I'll turn this off again. Ah, God. But you're not going to be using this with a large cutter. You're not going to be cutting this or running this at like 2,500 RPM and using a, I don't know, 12 millimeter cutter. Like, it's just not going to happen. It doesn't even fit in the chuck. So yeah, it tells us not to do it, then proceeds to see how far you can do it. Yeah, I specifically tried at the lower RPMs because I wanted to see if it does actually have more RPM at lower or more torque at lower RPMs. But yeah, don't try it at full speed because it also has some inertia. Feels like I'm still hearing it, but I'm not. Okay, will I be using Mach 3 breakout board? No Mach. I'll be using a rep style board for this. We'll be adding an emergency shutdown. Nah. All right, but that is going to be it for me for today. We've almost done 2 hours of live streaming. I will not have a live stream tomorrow. My dad's coming over. We're going on a bike ride. Priorities. But we will continue on Saturday with hopefully wiring. I will need to figure out something for these short wires and electronics and the main board. I'm still kind of set on using the Do It from the Mendel 9000. And yeah, thanks everyone for tuning in. It's been good fun. I'm really enjoying these live streams. Actually, I've just noticed that earlier today, or talked to myself like, dude, this is actually good fun. Especially the low latency, being able to see live chat, see you guys right there and then. That is so much better than having a huge latency. So yeah, thanks everyone for tuning in. Subscribe, like, you know the drill. Most of all, thank you all for being here, and I'll see you on Saturday. Same time, same place. Goodbye.